Okay, today we are going to start to revise our discrete system. And this is the notes from University of Oxford Engineering Department. So we will have 5 topics in total. First is introduction about digitalization, motivating examples, and etc. And second one is sampling. Sampling is really important, and we sample it and we reconstruct the signal, and the Nyquist sampling theorem will tell us the frequency needed to reconstruct, and the Euler approximation, which will always be used in our questions and exams. And for the analysis, then we will introduce the Z transform, the properties of Z transform, and some very typical examples using Z transform for those trigonometry, and some other examples we will introduce later. And we will come to the topic of convolution, and the convolution we will discuss in our later videos. And the discrete model of sampled data system, pulse transfer function models, the OH transfer functions, and the last one is step response and pole locations. It's important that you can revise this topic before moving on. So digitalization is a process to convert a continuous controller into a set of difference equations that can be implemented by a computer in a digital control system. The digital control system operates on the samples of the sensed output, resulting upon the analog to digital ADC conversion, rather than the continuous YT. And the advantage is accuracy and noise rejection. It's important to know some advantages because there will be some questions asking these. Okay, so I will leave 30 seconds for you to read this graph. Okay, let's move on. I normally skip the motivating examples. This won't be quite useful. Anyway, and we come to second topic, sampling in digital controls. Samples are analog to digital ADC usually produce a binary number. You remember this graph looks like this. And we will ignore the quantization error introduced by the finite precision representations. And it's important to know these equations because when you come to different units, you will be use different sample rate and the relationship between sample rate and the period. And it's also important to use k equals blah blah, these discrete numbers. This is called the sampling instance. It's important that you notice this because sometimes when you go through the notes yourself, you will probably miss some points and you find it in questions and you find it, okay, it didn't seem that I have come across this before. And the notation here is important as well. YKT equals YK and equals YK. So by sampling, we transfer it from the YT to YKT. And the YKT, you see here, it is a discrete signal. Reconstruction. Okay, so we have just done the sampling part. Then we want to reconstruct the signal. So you will be use a DAC. Okay, what is ADC? Analog to digital converter. And this is a digital to analog converter. It's important to understand the names because sometimes they will ask you to write down in exams. A piecewise constant signal produced by the ZOH. So this is to introduce the Nyquist-Shannon sampling theorem because when you give the two signals the same sample, it can be different waveforms. So the sampling theorem says a signal is uniquely defined by its samples, ykt, if the sampling frequency is more than twice the bandwidth of yt. We'll introduce it later when we come across those graphs. We didn't seem use this equation much, so we can just leave it there. And for example, consider a sinusoidal signal where frequency is omega and sampled at omega s. So because it's sinusoidal, so we give a cos omega t. By sampling, we translate from yt to ykt. So the k will be replaced by kt. And as t can be represented by omega s, so we will have this notation here. And next, sinusoidal from omega and omega s give identical equally spaced samples at a sampling frequency of omega s equals 8 pi. So for the same sampling, you can produce this different waveforms, so you can't reconstruct it accurately using the sampling frequency. So you have to be sample more, so you have sample more, then you'll get the exact waveform you want. So that's what it's saying here. So omega s minus omega, that is another wave that we want to try. And this is called alias. So next,